Okay, hello honors pre-calculus students. This is the video for section 2.4 notes. And this section is dealing with complex numbers and imaginary numbers. Let's get started. This first page, all of this is just showing you is kind of the evolution of numbers as you knew them. Starting way down here at the bottom with counting numbers. Counting numbers were, when you were a little kid, probably 1, 2 years old, you would start counting with 1, 2, 3, etc. Then whole numbers came in, and the funny thing about whole numbers is the only difference between counting numbers and whole numbers is 0. 0 was not a concept in history until I don't remember what year or when they decided to throw in a 0, but that was a whole new concept, the concept of 0. Then we go up to integers, and integers are like whole numbers except you can have negatives. So we could have like -3, -2, -1, 0, 1, 2, 3, etc. So negatives and positives, but they're still like whole numbers. Then you get up into rational numbers, and those are your fractions. Anything that can be written as a fraction is a rational number. And then we have irrational numbers. Irrational numbers would be something like pi or e. Those are decimals that go on forever, 3.14159, da 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 da. E is 2.71828, I think, something like that. Those go on. You cannot write these as a fraction. There's no exact fraction that equals pi or e, so they are irrational. All of these numbers are real numbers. And then we throw in imaginary numbers, and for the first time last year probably was when you learned about imaginary numbers. Imaginary numbers deal with I, and we'll talk about that in a second. But if you take a real and an imaginary and you put them together, then you get complex. So that's what we're going to be focusing on in this section. Okay? Next page. Okay, this is kind of the introduction into what I is all about. I is when you take the square root of -1. That's the definition of I. Because before you learned about imaginary numbers, you were told that you couldn't take the square root of a negative number. But then now we're saying, okay, you can take the square root of a negative, but it's imaginary. Now you can do kind of different things with them. We can fill in all of these if we use this general property here. So like for example with I squared, if I took I, which is the square root of -1, and I square it, so that's I squared, the square will cancel off the square root and I'll just be left with a -1. That is one to really remember. I squared is equal to -1. That's going to come up in a lot of problems. Basically, anytime you see an I squared, put in a -1. We can kind of keep going with that theme. I cubed. I mean, technically we could write I cubed as I squared times another I. That would make I cubed. Well, we just got done saying that I squared is -1. So we've got a -1 times an I. That would just be a -I. So if you ever saw an I cubed, you could put in a -I. I to the fourth. We could write that as I squared times another I squared. And we know from up here that I squared is -1, so we would have a -1 times another -1, and we would get a 1. So anytime you see an I to the fourth, you can put in a 1. And you can go through these other ones. You know, there might be some challenge problems, but basically you're just breaking it up. Like on this one, we could say I squared times I squared times an I. Well, I squared is -1. So you'd have -1 times another -1 times an I. Well, that will just be I. Okay, so we're not going to go through any more of those, but that's the general idea. I squared is -1. This page is just showing you what complex numbers look like. They're not problems that we have to solve or anything. These are just what complex numbers look like. You have a real part and you have an imaginary part. Here, the real part would technically like be 0. So you have a real part and an imaginary part, a real part and an imaginary part. That's all there is to complex numbers. This is the standard form, a plus bi. So if the book ever asks you to put a problem in standard form, it looks like this, a plus bi. Okay, we're going to do some simplifying problems. So for this first one, here I'll get these written in a little bit darker so you can see. Okay, so for this first one, you could write this as the square root of 16 times the square root of -1, because 16 times -1 is -16. The square root of 16 is 4, and the square root of -1 is an I. So the square root of -16 is 4i. Square root of -27, we could write that. There's a perfect square that goes into 27, 9. So we could write that as the square root of 9 times the square root of 3 times the square root of -1. 9 times 3 times -1 is -27. The square root of 9 is 3. Leave that root 3 alone. And the square root of -1 is I. Now I don't like putting that I at the end because if you're a sloppy writer, it might look like I is underneath the square root, but I don't want it to be under the square root. So I'm going to put the I next to the 3 and then do the square root. Okay, for this one, we can write this as the square root of 9 times the square root of -1. The square root of 9 is 3. The square root of -1 is I. Those do not combine. They're not like terms. In order for you to add them, they would both have to have an I. That's a complex number. Just like on that last page, we have a real part and an imaginary part. That's just like that a plus bi. That's that standard form. Over here, you can't combine those. They're not like terms. This has an I squared. That's an I. But remember a couple pages ago, what is I squared the same thing as? -1. So we've got a -3 times a -1, which is a +3. And then we've got that I, and you cannot combine those. They're not like terms. Okay, next page. If we're going to add and subtract, just combine like terms. That's all you have to do is combine like terms. So here I'm going to combine the 3 plus the 2, and I'm going to get a 5. And then I'm going to take a -I plus a 3i, and I'll get a 2i. That's it. It's just combining like terms. Over here, I really don't need those parentheses. I could just rewrite it as 2i minus 4 minus 2i. If I combine like terms, the 2i and the negative 2i cancel, and you just are left with a negative 4. On number 3, I would distribute the negative sign through, so I would have 3, but then a plus 2, and a minus 3i, minus 5, plus I, and then combine your like terms. So we've got a 3 plus 2 minus 5, so that goes away, and then a negative 3i plus an I is a negative 2i. And then over here, we have 3 plus 2i plus 4 minus I. Distribute the negative, so a negative 7. Distribute the negative, so a negative I. Combine like terms. 3 plus 4 minus 7. Again, that goes away. 2i minus I minus another I. Nothing. 0. This page, we're going to graph imaginary numbers. So on the x-axis, that's your real numbers. The y-axis are your imaginary numbers. So for A, I'm just doing negative 3. Negative 3 is a real number, so I'm just going to go to negative 3 on the real number axis. That's it. 3 plus 2i, I'm going to go 3 on the real and 2 on the imaginary. So go over 3 on the real and up 2 on the imaginary, and that's 3 plus 2i. For C, I'm going to go negative 2 on the real and 1 on the imaginary. So negative 2 on the real, 1 on the imaginary. And then for D, there's no real part to that, just imaginary, so I'm just going to go 4 on the imaginary. And that's it. That's graphing complex numbers. Then we get into multiplying and dividing. So this, you just multiply just like you would like foiling and distributing. There's nothing else crazy about it. So let's FOIL. First, we would get a 12. Outside, we would get a negative 20i. Inside, we'd get a 6i. And last, we would get a negative 10i squared. So let's combine like terms. A negative 20i plus 6i. We're going to get a negative 14i. And then we've got that minus 10i squared. But the I squared, that's the same thing as a negative 1. So we've got a 12 plus 10, so 22, and then the minus 14i. And then over here, distribute the 4i through. We'd have a negative 4i, and then a positive 20i squared. And I squared is the same thing as negative 1. So then we would have, if I put it in standard form, I would have the negative 20 first, and then the minus 4i second. Because remember that form A plus BI is the standard form for a complex number. It doesn't matter if it's a plus or a minus. Okay, I have to stop here, but there's going to be a second video. So when you're done with this now, go to the second video because I can only record so much at a time. There's more to the lesson, so don't just stop here. Okay.